There is too much trash in the street. To help curb the problem of littering, we built StreetSweep, an app that passively collects garbage analytics from cities around the world. StreetSweep uses computer vision and machine learning to give governments and volunteer organizations access to quantifiable information about the volume and composition of littering. In essence, it can detect the type of garbage in any crowdsourced geotagged photo and analyze that data in aggregate.
The images can come from anywhere, even pictures taken from fast moving vehicles. Anyone who visits the website is able to see a public board of where trash is in their area. Our hope is that this enables concentrated efforts to reduce the amount of trash on the streets due to the increased information flow. Users can monitor how many reports of garbage there have been in each area, as well as gain quantifiable estimates for what percentage of that garbage was recyclable, how much was biodegradable, and how much needed to go directly to a landfill. Now we'll talk a bit about how it works internally. When a user submits an image, it is uploaded to our Flask server, which triggers the machine learning that classifies the trash in each image. Because we had a difficult time finding a complete and well-balanced dataset for locating the garbage, we decided to adapt an existing network, a ResNet 101 classifier pre-trained on the ImageNet dataset that runs on PyTorch, to work with a model that generated bounding boxes for generic objects. First, the image is sent to the generic object detector. This is blind to the type of object it detects. It simply chooses bounding boxes for regions that are likely to belong to the same object. Then, those bounding boxes are cropped and classified using the ResNet 101.
After we generate and classify the objects in each image, we make an annotated report using OpenCV's graphics tools, persist it to the disk, and make it publicly available via the API. Each report is stored with a corresponding timestamp and geolocation, so we can render the volume of reports for each location on a heat map, as well as when those reports are filed. To make the heat map, we use the Google Cloud Maps API. Below the heat map, we have a responsive list that we made with React that automatically updates based on the viewport to show the reports for the selected region of the map. We also display the bounding boxes and annotations for each report so that users can understand what the model is detecting and also potentially crowdsource human-authored annotations for each image and help improve the model.
This technology is currently integrated as a crowdsourced app, but in the future, we will integrate it with a camera mounted on city buses and garbage surveying drones. This will allow for fully autonomous analytics collection. And now it's time for the demo.
I will now demonstrate StreetSweep. This is a heat map that shows where all the submissions for garbage have been made. Let's say I want to make a new submission at Tyson's. I drag the map such that the crosshair is over the Tyson's label. Then, I can upload a file that contains an image of the litter that I want to report. I'm going to open litter0.jpg. This is what the file looks like. Later, we will see what this looks like with annotations by the model. So I click upload, and you'll notice that a new marker is added to the heat map, as well as a new report is added to this bottom section over here. If I open the new report, I can see that this picture is annotated with the localized garbage collection items by the model. Now, some human intervention is required to make this perfect. However, because this is a crowdsourced project, we anticipate this, and this level of intervention will go down over time with more data and more annotations that we collect. Now, these reports would be overwhelming if all of the reports for the United States were shown down here. So the reports are only shown for the heat maps that are in the current view of the map. So let's say I move over here down to Western Virginia, and now only reports for this section of Virginia are shown. This enables policymakers to focus on only the most relevant reports for trash that they need. Thank you for watching.